So quick review what we did here in H7. Basically the stuff we've been doing, right? If you're going to factor something, always look for what first? And sometimes it makes your life easy, right? It's simple, get halfway done with the factoring there in part B, etc. This was one like we just looked at on the homework, right? It looks factored, but it's not, right? What's the common factor between these two terms? So that factors out, right? Now, had that been a minus, I would need minus parentheses here, right? And then distribute it through. I mean, technically, plus parentheses distribute to 1, but it doesn't change anything, right? Okay, then you get these two factors, set them equal to 0, right? Oh, what else do we do? You got to remember how to do the A times C method, right? Remember how to do that? I hope so. Okay. So yeah, I think I changed this one from the way they wanted to do it, but yeah, just factor it. And then we had stuff with cubics, right? This does not graph a parabola, does it? It's kind of a squiggly, snake-looking thing, right? And how many times? Well, how many zeros would a cubic have? Like how many times can it hit the x-axis? It could hit 3 times, right? All right. And so you get 3 zeros, or 3 solutions, or 3 roots, right? Or 3 x-intercepts. So what we do? Take a look at this one here. So we look for what first? GCF, which was x, yeah? And then when we did that, in this case, what got left inside the parentheses that we could factor again? A difference of what? A difference of 2 squares, right? Is x squared a perfect square? Yeah. Is 9 a perfect square? Yeah. Is that a difference, right? So that's why, right? It ends up being a plus b times a minus b, but we still have the x we factored out, right? Here's my a plus b times a minus b, and then you just set all those factors, all 3 of them equal to 0. Okay? And the 3 and negative, remember you can use this shorthand down here, the plus or minus 3 if you want to. All right. And we do another one like it? No, they just did another one. That's just the simplified version here, right? Oh, remember how to put things in vertex form? What do? What's this called? Oh, no. You what? Not find the square, but we what? Complete the square, right? Which means we add b over 2 squared, and then do what? Subtract it again, right? Then this thing here, trinomial, becomes a perfect square binomial. Combine those. Remember, to get the vertex, what do you do to the sign of the thing inside? Switch it, right? So that's positive and the 4 comma negative 1, right? And by the way, that vertex, what line goes through that vertex of any parabola? What do we call this line here? This dotted line. The what? The axis of symmetry, right? Okay, so it goes through the vertex. What was the x coordinate of this vertex? So it's over 4. So this line goes through 4 on the x-axis. So what's its equation? What axis does it cut? It cuts the 4-axis? Okay. So what's the equation of this line? In other words, what am I pointing at? Fork is not an equation. X equals 4, right? If the vertex is 4 comma anything, the equation of the axis of symmetry is going to be x equals 4, no matter what the y is down here. Okay? And what do you know about the distance on each side of the axis of symmetry to the parabola? Exactly the same, right? So like these 2 points here, where it hits the x-axis, What's one way to find where the axis of symmetry hits? Yeah, what is this point? X equals 3, and this is x equals 5. Right? So the axis of symmetry is found where? Exactly halfway between the two intercepts, right? And like mathematically, how do you find the number that's halfway between two others? Take the average, right? Yeah, you could look at that and say, yeah, halfway between 3 and 5 is 4. But sometimes it's harder to see, right? But take the average of the two numbers. Wouldn't that give you the exact middle? How do you take an average of two numbers? That's it? Just add them?
No, you multiply by 2.
Add them up and divide by 2. So you take the average of two things. They take the average of 5 things.
Add them all, divide by 5.
Okay, so you take the average of 2 things.
Add them all, divide by
What's 5 plus 3?
8.
Divided by 2. 4. Okay, that gets you exactly halfway, right? So look, like in this one here, they wanted to know the equation of the axis of symmetry, right? So if we found the zeros at -3 and 7, well, maybe that's a little tougher to see exactly what's halfway, right? So can you add these two and divide by 2? There's the equation of axis of symmetry. Equals to x equals 2. Right? Remember doing this
Yeah,
not too long ago? Huh?
that was way too long ago, like years ago.
Years ago or Friday.
4 days ago.
Okay.
I just did trade and went to the science class. I think I learned that fast. I didn't do this.
You did trig, sine, cosine, tangent, all that stuff. Obstacle, hypotenuse,
Yeah,
base,
for like
you what?
for the American time, we did like this.
Oh yeah, well, like an angle to fire it? Yeah. Well, so what's the optimum angle? To get the greatest distance out of a
I
projectile.
have to see the problem. I can't just do it in
No,
my
it's the same answer for any projectile. What's the optimum launch angle?
35.
I was usually, I don't do that. I
So,
mean, I did it, but like,
No, let's just.
so let's take a look at the Regents questions now that we've reviewed a bit. Okay? Let's look at that first one there. See that over?
The zeros of the function at x equals
Wait. Zeros of the function what?
f of x.
Say it again.
F of x.
Yep.
Here's the fx.
So what's the first thing we're going to do? Just like in the homework. Serenity.
Minus DCF.
Well, first, before that, define the zeros.
Equal 0.
Right.
Set it.
So, whoops, I don't want red. Silly.
You write f of x, and you just write x.
No, because f of x is going to, so this is going to be 0 equals that. But we just move it to the backside, right? Because that's where f of x, the value of the function, will be 0, where it hits the x-axis, right? So x cubed minus 9x squared
Equals 0.
equals 0.
Actually, equals, like, it's already doing this problem, or if we don't do it. I'm not doing it.
Why aren't you doing it? What's the first thing you look for?
But GCF.
Dude, what's the GCF?
X.
How about x squared out of both? That's the greatest, right? X is a CF, but it's not a GF.
Oh my god.
She's had enough of you people.
Yeah, everything.
I don't know how to do this.
So what's the greatest common factor in both of these terms? X squared. What's that leave us inside? X cubed divided by x squared is x to the first minus 9 equals 0. Now I have a question for you, because this looks a little like the one we did in the notes.
Yeah.
Is that, Emily, is that x minus 9 a difference of two perfect squares?
Sure.
Yeah.
Well, you tell me why it's a difference of two squares. Do you see two perfect squares there?
Yeah, kind of.
The 9 is a perfect square.
Yeah.
What about the x?
No.
No. Yeah, right. And yet on the notes it was x squared minus 9.
So
Is this that? So it's not. So can we factor it anymore?
no.
No. So what do we do with the two factors? So speak.
Set it to 0.
So tell me what to write.
X minus 9
X squared,
equals 0.
0.
X minus 9.
What does x equal over here?
Zero.
X equals 0, or x equals
X, 3, 9.
9. Just add 9 to both sides.
I was trying to figure out why you changed it. I was swearing.
So it's choice 2. But look, see what they did? They put them in there, in case you thought that was a difference of 2 squares there.
That's what I did.
That's what they do. Okay. Let's move on to the second one. Some polynomial function.
I'm just gonna take a wild guess.
Well, you can take a look at that and know that's a cubic, right?
Mhm.
Something with x to the third anyway.
Yeah, because it used to think 3 times.
Well, which function could represent this graph? Well, what should we look for, by the way? You see all the choices are in factored form?
How many X's there are? We've got
How many,
0.
you mean to say zeros, right? Or what are they? What are the, just write them down. What are the zeros of this? What's this 0? That's x equals -2. What's this one?
1.
1, and what else?
X equals 2.
So those are the 3 zeros, aren't they? Aren't they?
Yes.
So let's find one of these that has all 3 of those zeros. So like in this first choice here, what would I do with these 2 factors to find the 0? What do we always do when we have
Set
factors?
them to 0.
Set them each equal to 0, right? If x plus 1 equals 0, what does x equal?
0. -1.
So this would be x equals -1. Oh, wait a minute, is that even one of our zeros?
Nope.
No, it's not. So how about this one? If these were both set equal to 0,
X
this would be x equals 1. Well, wait a minute. This would be, you'd add 4 to both sides, right? You get x squared equals 4.
So you can cross off
So what would x equal?
2.
If you take the square root, guys, if you take the square root of both sides, what do you get here?
2.
What else?
-2.
Plus or minus 2.
Is that one then?
Is it? You tell me.
Yeah, it is. Because there's a -2 and 1.
All right, so you see, when if they give you a question like that, and all your choices are in factored form, you know you can find the zeros real quick by just setting these those factors equal to 0, and they just have to match the zeros in the graph, right? It's not too hard. Choice, yeah, choice 3. You get that though? And again, when you take the square root of a number, how many answers do you really get? Yeah, the positive and negative. Okay? Moving on. Okay. 3 functions. Read this over. You reading that?
It's not labeled.
Not labeled with what?
Well, you're gonna have 3 functions on the thing. Why is it not labeled?
What's not labeled?
You can put parabola.
Well, here's function A, that's g of x. Here's my second function B, that's f of x. My third function C is what?
H
H of x.
That's 1.
So they gave us 2 functions in equation form and 1 as a graph. So, look at the question. We're asking about zeros, maximums, minimums, y-intercepts in this one.
With number 3, it has C and Chad.
Yeah, it should be a space there. C has, not Chaz.
C Chad.
Chaz is actually short for Charlie, for Charles.
You look like you would be a total.
Well, should we take a look at these one at a time? Will B and C have the same zeros?
B zeros is -2, -6.
How did you get that?
I set them to 0.
Because if you set those equal to 0, like subtract 2 from both sides, right? You get zeros of -2, -6 for that one. What are the zeros here?
-2 and -6.
So do they have the same zeros, B and C?
No.
No.
Because you go to.
Wait. What now? Here?
0.
Like in this one? This is where,
I don't know, just. Are you talking about the graph or for B?
so you know how when they ask you to find the 0, it's like you take the equation, set it equal to 0, right? And then we factor it, right? That's at that point, each factor, and then you set each factor equal to 0. So you'd have x plus 2 equals 0, or plus 6 equals 0. What's x equal here when you subtract 2 from both sides? And over here, Hannah.
Hannah, so right, Hannah. You
Subtract,
forgot your or.
subtract 6 from both sides.
Yeah, you forgot your or. 0. Subtract 6.
Yeah, what's 0 minus 6? This thing I don't do anymore.
6.
No,
-6.
-6.
Oh, you got us for missing our or.
Yeah.
Yeah, you just got 5.6 off. Yeah.
Anyway, yeah, 5, sure. But that's how I get that. And you get the zeros from the graph by, well, that's where the graph, the value of it equals 0 twice there. So number 1 is no.
Yeah.
Okay. B has a minimum and C has a maximum. Well, take a look at B.
Yeah.
Does that have a, what is that? Does- Does C have a maximum?
Yeah.
Yeah. But does B have a minimum? Well, is it concave up or concave down? Is like, to be concave down, wouldn't it have to have a negative sign outside in front of that?
Yeah.
Does it have that?
No.
No, right? So this is concave up. And so it has what? A minimum.
So 3 is right.
That's our answer.
B has a minimum and C has.
Why does B have a minimum? Because it's concave up, right? So that vertex is a minimum. Why does C have a max? Concave down, so the vertex is a maximum. You can tell very easily that this is concave up, right? Because there's not a negative out in front of it, right? Okay.
Yes, you're right.
I usually have.
Yeah.
Okay, moving on. Read it over. Wait. Oh, this is period 2. Holy cow, 11:42?
What?
This period's over 11:42?
Yeah.
Holy smokes.
What time is that?
11:40. You need CPR, chest compressions.
I was thinking inhaler. I got one of those. Ooh, that's like-
Okay, well, why don't we just pause it here?
No,
No.
I got 30.
Okay, how many more left?
I don't care.
Good Lord.
I got like a whole
I have like
week.
a 3-part video series for this lesson. All right. Now, we're going to pause it here.
B.